What's going on? So this video is about 5 C++ features that are illegal in high-level synthesis. So the first one is dynamic allocation. So in normal C++, you can do things like create a class, and then you can use this new keyword to create a pointer to an instance of that class, and this pointer refers to a location in the heap. In high-level synthesis, you can't use new. You can't have dynamic allocation. You can't allocate memory while the program is running because it's not actually a program. The program is a description of hardware, and memory is a fixed resource that's built into the design at compile time. So there's no dynamic allocation in high-level synthesis. Number 2 is recursion. So in software, you have a stack, and the processor maintains a stack pointer that keeps track of where you are in the stack. And functions that have been called can simply call themselves again in a recursive fashion and have, the stack frame incremented and put new variables onto the stack and do this kind of recursive call. In high-level synthesis, the functions that you write are really finite state machines with limited storage, and there's a static mapping from variables in the function to registers in the synthesized hardware. And some high-level synthesis tools can do things that are a little bit more dynamic, but in general, recursion is banned because the generated code is not CPU-like. It doesn't have a stack frame. It doesn't have, extensible memory that can be used to support this kind of recursive call. Number 3 is exceptions. So you can do things like, say, in C++, you can check, for example, if b is 0 before doing a divide and throw divide by 0 if there is a divide, and it's up to the caller of this function to handle this possible exception condition. In hardware, all of these functions just become modules. String constants are like divide by 0 are completely meaningless. And you really need to explicitly handle everything that could happen in a module in the normal course of control flow. There's no high-level synthesis tool I know of which supports C++ exceptions. Number 4 is virtual methods. So in software, you can have things like you can declare a class foo, and then you can have 2 different classes that inherit from foo and override bar, returning 1 or 2 from myfunc. And then you can do something like call virtual. You can pass in a pointer to something of type foo and call myfunc. And at runtime, the software implementation will actually look up which type this foo happens to be, whether it's bar or zoo or actually just an instance of foo. And it'll look up the appropriate address for the appropriate version of myfunc that needs to be called here. In hardware, functions become modules. There's no compiler-generated address tables because there's no addresses. And in general, in high-level synthesis, what you'll see is that there is no support for virtual methods unless the method can actually be statically resolved so that you don't need a table somewhere in the hardware to figure out which module to invoke when a function is called. So in general, in high-level synthesis, you have to avoid virtual methods. And the last one is the C++ standard library. So, of course, when you program in ordinary C++, you can do things like use standard lib and have std vectors and dex and string conversion and all kinds of interesting things. And in high-level synthesis, that is banned. So first of all, the vast majority of the stuff in the C++ standard library would require one of the aforementioned banned features like dynamic allocation or recursion to implement, and so they're totally out of the question. And in practice in hardware, there's no standard library implementation to link to in your target. Your target is just silicon. So typically each HLS tool will come with its own sort of standard library, which includes primitives that can be implemented in hardware and that are more relevant to high-level synthesis. So those are 5 features to avoid when you're writing high-level synthesis because they're almost certainly not supported in HLS compilers. And with that, I'll see you in the next video.